Thank you, and welcome everybody. My name's Jeremy Heath. Let me just tell you a little bit about myself. I work for SES Water. That's a small water company just south of London. I've 25 years experience in the water industry. My background is mechanical engineering, but I'm also a coder as well. I wrote a lot of our systems here at SES Water. And about 5 years ago, I was asked to start managing innovation formally at my company. I've been doing it for a number of years, kind of on an ad hoc basis, but this was to devote myself to innovation at SES Water. And that's twofold. We look at trying to build an innovation culture. So we are capturing kind of what we call bottom-up innovation. That's employee suggestions and ideas. But also I have a wide brief to look around for new technologies in the water industry and how we can introduce those into our company. And a particular area that I'm looking at the moment is smart water networks. So that's smart metering, looking at artificial intelligence, IoT communications. And at SES Water, we've got a very good smart water network already running that we're looking to expand across our company. About 2 years ago, I was asked to speak at a conference on innovation in leakage. And the reason for that is because I used to run the leakage for my own company, and again, wrote a number of systems to deal with that. But I was asked to speak about, on a national level, what innovations were coming through. And there was a reason for this, is because in the UK, we are facing a enhanced drivers, I think would be the best way of putting it, on leakage. And that is because our regulator, Ofwat, has said that every water company must reduce their leakage by at least 15%, and sometimes more, so 20, 25%. And that's a real challenge for our industry at the moment, particularly for some companies that have been very steady state for a long time. So it's driving a lot of interest in innovation in water leakage in the UK. So I was asked to speak on that. Following my talk, I was then asked to head up the National Zero Leakage Project. Now that's being run by a group called UKWIR, the United Kingdom Water Industry Research. And they effectively are a joint organisation for all of the water companies in the UK that draws together research ideas and puts those through. And so I'm responsible for driving the UK Leakage Research Programme. What does that look like? So at the top, we have what's called our big question. There are 12 big questions in the UK. I'm responsible for big question 2. How do we achieve zero leakage in a sustainable way by 2050? That is what we call a big, hairy, audacious goal, meaning it's something huge up there to aim for. Okay, that's our moonshot. Underneath that, you'll see prevent, aware, locate, mend. This is something that I use when I talk about leakage, the acronym PALM, prevent, aware, locate, mend, because I always explain that to do leakage properly, you've got to be good in all of those areas. Most people that look at leakage are very concentrated on awareness and location. That's what leakage managers tend to be incentivized to do. How many leaks are you finding? Mend tends to be outsourced to their contractors to actually carry out the repair work, and prevent tends to be dealt with by the asset management team and how the network is replaced and operated. What I'm arguing is that anybody that's involved in leakage has to be looking at all 4 of those areas to start driving down leakage within their company. Below that, we see the 6 outcomes that we are trying to achieve in order to get towards zero leakage and the benefits that come out from that. And then at the bottom, you can see the projects that we are currently working on or have completed. So we've been running this program for a couple of years now, and you can see there's a number of completed projects there in blue. Green is live projects at the moment. We've got the orange ones in planned, and then the kind of goldy coloured ones there, which are our ideas and where we're looking at. So that's the route map. Now, when I took over, I looked at the route map and I said, okay, I can see where this project list came from. There was a big discussion between all the companies when this was first set up, and we identified the kind of projects we wanted to look at. But I was struck by a comment I had from somebody who said, why are we working in these areas? Because there's a lot of knowledge within the water companies and a lot of research taking place that's duplicating this work that we're carrying out. And so I decided at that point that we needed to do some work to understand what was going on within the water company. What we needed to do was to get a leakage innovation heat map for the UK. So I started working towards that. And the idea was to generate, as I said, industry-wide innovation heat map for leakage and it captures the current research programs or recently completed research programs that have taken place. Okay, two aims behind that. One is that this would assist in the development of our big question. I wanted to find where was there little research taking place at the moment. That's where I want to be doing my research, is where nobody is looking at that. Okay, I'm trying to understand where the gaps are occurring. But also, with all of the work that's going on and the drivers from our regulator, I wanted to look at how I could foster collaboration between companies and say, look, there's a number of you working on the same projects. Why don't you start working together? It is sadly true of the UK water industry that in terms of innovation, we have more pilots than Gatwick Airport, our local airport, and we have more trials than the old jury. And we do have an awful lot of pilots and trials. Everybody wants to try something out themselves. And one of the things I wanted to do was to say, look, why don't we start collaborating? If we're all working in the same area, don't run all your own separate stuff, start working together. So as I said, 17 water companies, England, Scotland and Wales contributed, and we got 328 projects that they put forward, saying what they were working on. And in April, we published this on the UKWIR website. It's available. Hopefully some of you will have already downloaded that and had a look. If you haven't, do head over there now and download a copy. I'm actually going to go through that now and explain it, but if you've got your own copy sitting in front of you, feel free to use that as well and ask questions about anything that comes up on that, because obviously there's a lot more detail on that. What you'll find is on that site, there is the route map there, but also the heat map, and the heat map is a self-contained Excel spreadsheet with a number of tabs, and that's roughly what I'm going to take you through now. So, what did we collect? Well, this is the kind of sample data from the project list. So we said, okay, in the description, that breaks it down into those 6 outcomes that we were looking at. So we divide it into 6 areas. But below that, we have the different project types, which is a subdivision. And there's about 30 different project types. So we can group things together and say, who's doing work in similar areas? Obviously, you've got the company there, and then what they call that project. So if you're talking with them, you know roughly what to ask them about. And a project description. We have the project cost as well. Now, that's very wide. It's simply less than 100K, 100 to 500K, greater than 500K. And obviously, some people will say, I'm not prepared to say how much we're spending on that. The only reason we're collecting that information is it gives us some idea of the size of the project, okay? Project status, is it active investigation, all the way through to project completed on a 5. We do collect project abandoned as well as a status 4. Really useful to know that somebody started doing some innovation work and then said, actually, we're not getting the results we want, and we're going to abandon that. And then some idea of when the results are going to be coming out, when their findings would be on the column there. Now, that's what everybody can see. The water companies get another column as well. And the other column that the water companies can see is willingness to share. And that basically says for every single project, the water companies have said, how willing am I to share my data or findings for this particular project? And that goes from, I'm not willing to share anything at all the way through to, I'll share all the project data. The reason we're interested in that is because that massively helps with collaboration. I said that we do a lot of trials and pilots. One of the reasons for that is because we can't see the other company's data. And even though their findings may have said, yeah, it worked for us, the nervousness is, well, it may have worked for them in that particular situation, but we don't know what they were trialing it on, and we don't see the actual data that they got. So one of the things I wanted to encourage the companies to do was to share their data. And so the companies have said, yeah, this is how willing I am to share that, based upon either, I'm not going to share anything, I'll tell you I'm doing it, that's it, I'll share my findings, I'll share selected data, or I'll share all of my data that came out from that project. So, of course, the first question that immediately rises from that is, well, how successful was that? Well, this is a project count by willingness to share. And the great news is the whole of that left-hand segment, share all project data, share selected project data, 52% of projects, companies are willing to share their underlying data that they use to base their decision on whether they were going to use that product or not. Now, that's massively useful to other water companies. They can have a look at that data and they can say, right, that will be really useful to us because it helps us make informed decisions. Even on the other projects there, 27% over another quarter are willing to share their findings. Again, really, really useful data. Now, what I haven't done is I haven't set up a data sharing facility. I've not provided that. And what I have said, as you'll see on the spreadsheet, is it says that this is an indication the company is willing to share, and another water company will need to approach them and say, look, you've said that you're willing to share data on that one. Can we do a reciprocal arrangement? We'll share our data on this project, and you share your data on that project, or could we come to some agreement about seeing that data? But it's great news that we're seeing so much willingness to share information between the water companies there. So where does it show us in terms of our actual heat map? And when I talk about a heat map, this is generally the slide that I mean. So this breaks it down into the 6 different outcomes that we're looking at, and beneath those, the various project types. So each of these is project counts, that's the first number you see in the column, and then the project scores, or the total scores for those projects. Every project is scored out of a maximum of 40. That is based upon the usefulness of that project to the wider water industry. Obviously, every company did that project because it was useful for themselves, but I want to gauge how useful that is for everybody else. So a maximum of 40 would go to a project which is completed, so all the data is available, large, greater than 500K, and where they're willing to share all of the data. That would be a maximum of 40, and there's a sliding scale below that that goes down. So that gives an indication of how valuable that research is to the wider industry in that particular area. So what does it tell us? Well, looking at the scores, straight away, our eye is drawn to the bottom left. All new leaks are found quickly after they break out. I spoke about PALM earlier, prevent, aware, locate, amend. Well, that one down there is the awareness and location. And it's no surprise to find that most of our research from the leakage community is going into that particular area. So you can see there's a lot of work going on into non-acoustic leakage location. These will be things like pressure sensors, so looking for localized pressure drops, satellite surveys, systems, fiber optics, and things like that. All of those methods come into there, and there's a lot of research taking place in that area, far more than we see in the acoustics. And that's probably because acoustics is far more of a well-developed solution these days. There's some research going into optimizing the acoustics, but non-acoustics is a big growth area at the moment. A lot of companies are looking at that. We're seeing quite a bit of work on, obviously, network leakage awareness. Where do we go and look? Okay. Not the location side, more about which areas of my network are the most leaky, where have I got the most problems coming from, and a lot of our smart networks fall into that category there, network leakage awareness. So yes, absolutely expected, a lot of work going into that area. It doesn't mean I don't think we're going to drop any research in that area, but if we do anything, it will be concentrated into poor areas, or it will be about sharing best practice. So if a number of companies are working on satellite, or a number of companies are working on other areas, that we may start to do drawing together and saying, okay, what's the best practice in this area, rather than doing fundamental research in those ones. So the next largest area is we look on the top right. Confidently quantify leakage and demonstrate when it's zero. And straight away, you can see that almost all of the research in that area is about property allowances. In the UK, we calculate leakage in a slightly different way to the rest of the world. We have a bottom-up methodology. So part of the reason for this is that when we first started looking at leakage back in the 80s, we were predominantly unmetered in the UK. And therefore, it's very, very difficult to do a top-down non-revenue water measurement. So therefore, the UK water industry came up with a different way of doing it, which was to look at the night lines at 3 o'clock in the morning, to say, okay, there is an allowance in there for usage at that time, and everything else is leakage. We have a small allowance that's allowed for property leakage, but it is very small. And in fact, some research we've just done recently shows that that's 3 times lower than it should be. But the upshot of that is it's very important for us to know how much leakage is occurring on the customer's side, so on the supply pipe or internal plumbing losses, because it massively affects our leakage calculations. So most of that work has been because we've just done a fresh asset management plan. We have to do one every 5 years for our regulator. And a lot of companies have had to put research in to say, okay, what is the correct level for my internal plumbing and my supply pipe losses? My expectation is that figure will drop dramatically in the next couple of years. We're planning on running this exercise every year, but I think that will drop off dramatically because that was done primarily as an exercise for this current asset management period. So again, we then look at the center middle. New leaks on existing networks are minimized. And three kind of areas there that a lot of work is going into: network pressure optimization. How can we lower pressures within our network to, I'm not going to say the absolute minimum, because obviously then you start to get into customer complaint side, but how can we drive pressure down in an optimal manner? There's a lot of work going on with control, with having control points within DMAs, and there's some work going on actually with multiple control points within DMAs to see how we can actually bring down pressure to a very low level. Mains condition surveying falls into there as well. How can we make sure that our mains are, that we're replacing the right mains? My own company is doing a lot of work in that area. We have one of the highest replacement rates in the UK. We are investing quite a bit in our network. We want to make sure we're replacing the right pipes. There's a lot of work going on into non-destructive testing of pipes so that we can understand their condition. And then, of course, network calming. It's interesting. I was chatting to someone in our control room recently, and we were talking about the fact that we are now aware of how many transients, pressure transients, there are going through our network. He's one of the old boys. He's been in the industry for 40 years. He said, well, of course, you lost the transient information when you all went digital. I said, what do you mean? He said, well, he said, in the old days, he said, when I started at the company, I was sent out with a stopwatch and a pressure gauge and asked to sit out on the network at 3 o'clock in the morning to measure the pressures. We didn't have loggers back then. And he said, so I'd be noting down the pressures at various times. But you would see the pressure waves going through the system because the pressure gauge would be reacting and swinging up and down. As soon as you went digital and started to put loggers out, you would average that pressure over 15 minutes. And so you would lose that information. It's only now that we're coming back and starting to understand how noisy our networks are. And so network calming is looking at how we can reduce those pressure transients going through, and quite a bit of research going into that area. So the two areas that I want to talk a little bit more about is the ones on the bottom middle and the top left. The top left, let's start with that. All new pipework is leak-free. Very, very little research going into that, but unfortunately that's a massive problem. So we're talking about PE pipe that's being laid at the moment, and the problem that we have of laying brand new PE pipe that doesn't leak. That's a huge issue. When I talk internationally and talk with other countries, I find that that's the case. I won't say with every single country, because some countries seem to do it a lot better, but across the world it seems to be a common problem. Okay, so what we're now doing with that, although there's very little research taking place in that area, in fact I'm working with the CEOs of the UK water companies, and we're now looking at how we can bring in better practices, and then starting to look in the long term at our fittings and how those are made, so that we can start to bring in the opportunity to lay leak-free networks. We're going to be looking at new build estates where we're laying all of the new pipework there, how we can ensure that we can lay a brand new estate that it doesn't leak at all. And that's a real challenge to do. So that's one of the areas that we're starting to branch into and look on that. But one of the major areas we need to investigate is that bottom middle. Repairs are quick, economic, with minimum disruption. When I coined the PALM acronym, it was partly because the M was my deepest concern, the MEND side of that. You see, we spend an awful lot of money and effort making sure that we can find leaks, but the repairs can take weeks, particularly in the UK if we're on a red route, so that's a very busy road. You're not allowed to park up easily on those ones, typically main thoroughfares going into London. We've got a number of those in our patch. Or where you have something like traffic lights or something like that, and it's very difficult to carry out that excavation. So you may find that leak within days, but it may take you weeks to carry out the repair. And all that time, that water is running. How can we speed up those repair techniques? And it's somewhere where I've been really pushing, because I can see that there's not a lot of work going on in that area. Repair process optimization is simply about trying to do it a little bit quicker, and generally that's about a process thing rather than a physical invention. So I've been talking to the United Kingdom Society for Trenchless Technology. We've been talking to the Pipeline Industry Guild and the various other groups to say, okay, how can we speed up research into our repair technology so we can actually start to do in situ repairs, micro excavation, where you just drop straight down on where the repair needs to occur. You have it very accurately, and then you can carry out that repair using long-handled tools and things like that. It's an area of where we're looking at a lot of growth in there. Bottom right, background leakage is eliminated. By background leakage, we mean leakage below the level of detection. These are your weeps and seeps, as it's commonly called. There's no research, as you can see, going into that at the moment, and that's understandable because companies are saying, do you know what, in the first case, I probably need to deal with the leaks I am aware of before I start getting into those areas. I think as we start to move through into those, as we start to drive our leakage down lower and lower, background leakage will become more of an issue, and we'll start to see more research going into that. But at the moment, I'm happy that that's not an area I need to concentrate on. So that's the heat map there, and that's the conclusions that we're starting to draw out from that. I spoke about collaboration earlier. This is the collaboration sheet. What this does is on the left-hand side, I have my project types coming down there. And on the top, you can see 17 numbers. Now, those are the individual water companies. For you, it's anonymized. For the water companies, they can actually see themselves and the other water companies as well, so they know who's working on what. The beauty behind this collaboration sheet is it very quickly allows companies to understand who's working in similar areas to them. So if you looked at one particular company and we look at, if we looked at one particular area, network pressure optimization, company 2, who is working in that area, now is very aware of who else is doing the same thing. And they may be saying, right, okay, let's start collaborating on the information that we're getting from that. And we're going to go and talk with company 8 and 11 and 12. And we'll talk with them and start to share information with them so that we're all working on the same idea together and start to do some collaboration on that. Really useful tool for all of the water companies, and we're starting to see them pick this up and start to use that for collaboration. What I love, though, is the opposite way of doing this is to say, okay, let's look at company 2, and they say, fine, I'm going to start looking at an area I'm not currently working in. So, for example, dynamic optimized networks. Dynamic networks are ones where the network is actually able to open up valves automatically in order to keep the system fed. Our network in the UK is divided into DMAs, district meter areas, typically about 1,000 properties. A dynamic network would be larger areas that can almost self-regulate and open up in the event of burst. This company 2 is not currently doing any work on that. What would they do normally? They would decide to run a pilot or do some trials, and they get the contractors in, they get the suppliers in to talk with them and say, okay, how do we start to do this? What they're able to do now, though, is to actually go to company 4, to company 9, and say, look, we know you're already doing work in this area. You said you're willing to share your data or your findings. Can we sit down and see what you've been doing already so that we don't duplicate the work that you've done? So we can take what you've done and start to apply that into our own area and learn from your best practice. It's a beautiful example of collaboration and being able to use this in order to be able to do that. So that's it in terms of the presentation, but doubtless that will raise a number of questions that people want to ask, and it may be about slides, and I can just work my way back through those. Or you may have downloaded a copy of the presentation and want to discuss some of the things, of the actual spreadsheet itself, and you want to discuss some of the items that are on there. So what I'm going to do now is I'm going to stop sharing my screen, and I'll kind of open myself up for questions on that. I can see the chat here, so as you start to bring in the questions, please feel welcome to ask away.
Thank you very much, Jeremy. That was very interesting, and it will be interesting to see what questions that come in. I have a question before people start typing them in, but have you considered sort of like collaboration with water utilities outside of the UK? So looking at international water utilities?
Yes, yes, we have. And in fact, when I started doing this, we were talking internationally as well, and the Australians were extremely interested in this. And also we found from other countries as well, the Dutch and people like that. Effectively, the upshot of that is the next time I'm running this, I have been asked by people from outside whether we can actually include them as well. So I'm interested in actually using this methodology and starting to turn this almost into an international system as well.
Right. So if there's any utilities listening into this, they can contact you directly and to ask questions.
If they'd like to let me know that they'd be interested in joining in with this next time round, I'd be really happy to include and start to run this more as an international exercise as well. I think it'd be wonderful to get to that state where we start to understand who is working on what internationally. And I find that, the only way that I know that somebody is working on something is when I go along to a conference and I hear a presentation. I think I'm doing exactly the same thing. I'm sure all of you have come across exactly that same situation. This gives us the opportunity to find out early and then start to do that collaboration work as well, but also to drive our research programs into those areas which aren't being investigated at the moment. So yeah, very happy for that.
Okay. We do have one question. I'm not sure whether this is one that you would answer, but what non-acoustic methods for leak detection are the most popular ones?
Right, so what I'm literally doing is as I'm talking, so I'm going on I've got a copy of the spreadsheet open here as well. Let me just go down. And I should be able to find the non-acoustic methods, yeah, and then filter upon that. I didn't have a filter on already. So yeah, so the ones that we're predominantly looking at the moment, pressure is a huge one. That's become a really interesting one in the UK. So let's look at the kind of various methods that you've got there. The problem that we get with the acoustic ones is acoustic doesn't find the biggest leak, it finds the noisiest leak, okay? So how do we start to change that is you're looking at things that aren't using that side. Sorry, I'm going to look down, sorry. While I'm talking, I'm trying to find the actual, that's it, there we go. Right, just looking down here. So the areas I can see is satellite imagery, thermal imaging, fiber optics, and yeah, pressure. Those are the major ones that they're looking at. And actually leak localization using transient pressures as well. So those are the main ones that are coming through, predominantly from about 3 or 4 companies I can see here who are doing an awful lot of work on that one. Sensors on joints as well, to try and find those ones. I think, you know, from my experience, so part of what I did is I also went around and did a leakage roadshow. So having done all of this, I wanted to talk through with everybody and understand what was going on, and just make sure they're all on board. So I travelled all the way across the UK. I went from Exeter in the south up to Edinburgh in the north in Scotland. I met with every single water company that had contributed and took them through the results and the findings. One of the major ones that came through is leak localization using pressure. A lot of companies are working on that at the moment in the UK and trying to use micro pressure variation, localized pressure drops in order to understand leak location. So there's a lot of work going on in the UK on that particular area.
Okay, we got a question or a comment from Stuart Hamilton, which is, it's concerning that contractors or consultants are not involved, and this is possible where most of the knowledge is. I mean, do you get contractors and consultants and manufacturers, I suppose, involved in this at all?
Yes, so again, when I first started rolling this out, I went through Paul Horton of the Future Water Association in the UK and asked for supply chain to be involved because I actually did want contractors and consultants to be involved in this. So he put it out through his own network and asked people to be engaged, and I had about 4 replies, which again, I agree with Stuart, is disappointing. Hopefully, as a result of this, we will start to and one of the reasons why I do these kind of webinars is to raise the awareness of this so that the next time I run this and then say, right, I'd like to get information back from the contractors and consultants, we'll get a larger return. Now, I recognise, particularly with them, there may be less willingness to share everything they're working on. And I'm not naive. I recognise that even within the water companies, this isn't a complete list of projects. There's stuff that I haven't been able to share simply because of NDAs and things that we're on. So it's not a complete list of projects, and I think when we talk with the consultant and supply chain, they will be nervous about how much they want to share, but I think it's a valuable resource as well. I think this is really useful for the supply chain as well, because they at least understand what the companies are interested in working on. And I think if you use particularly that active investigation status, that means the company hasn't signed anything yet. Effectively, they're going, I'm interested in this, but I'm looking around for partners. And if I was on the supply chain side, I would instantly be sorting on active investigation and then saying, right, okay, do these match up with what I'm working on? Because these are the companies I need to be talking to. That also brings in academia, and I did speak with the universities in the UK as well and start to try and get them involved. Again, I had a limited return from them. Again, I'm speaking to them now and hoping that now they can see the benefits of this. But the next time we run this exercise, we'll start to get a lot more from academia as well.
Okay, good. We have a question from Benoit. This is an impressive overview. Looking at the all new pipework is leak-free box, it strikes me that new pipe material solutions do not seem to be considered. Emphasis seems to be on repair with all the burden that comes to that, not replacement once and for all by e.g. stainless steel pipes. How ready are the mines to embrace solutions that feature less joints and easily last for decades?
So in fact, interesting enough, when I did this work, this was in late last year. It just took me probably the beginning of this year to kind of collate it, and so that's why it came out in April. At the end of last year, we were starting to see a lot of interest in stainless steel supply pipes in the UK, and I know that there's a number of projects going on within the water companies that are looking precisely at that. So I expect that the next time we run this, we will start to see that side coming through. But it's an interesting one as well. I think the all-new pipework one that's one side looking at the new build estates, but it's also our repair replacement policies as well and our asset health. It's an area which personally I feel we need to do a lot more work on in the UK, is getting a far better asset replacement rate than we currently are. So by way of example, one of the simple measures I look at is how much pipe are we replacing per year. My own company, we are doing about 0.7% per year. So that gives us a life on our mains of about, let's say 130, 140 years. There are companies within the UK, and you can go and look this up because it's in their business plans, whose replacement rate is 0.1% per year. That is saying their pipes will last for 1,000 years. When I did my roadshow and I met with them, I called out every company that was in that category and said, are you honestly telling me you think that it will last that long? And it's one of the areas which I've really got to push, because I think we need to have a good understanding of our underground asset health and a good understanding of getting value in terms of replacement of it as well. So yeah, very interested in stainless steel pipe, and I know that's occurring. There is a lot more acceptance now of what we're going to have to change and develop.
And is there any new pipe materials that are being looked at the moment? And I know probably PE was probably the last new material, but is there anything that's being looked at as a new material?
Not that I'm aware of, not that's come up from the heat map side. What is being looked at a lot more is rehabilitation techniques and how we can make better use of existing assets. So in fact, one of the projects which we're now just kicking off in the UK as part of our UKWIR research is looking at deterioration of cast iron. So I did a review of all of the literature when I kind of took over this role. One of the things that surprised me is although we can do some kind of predictions on material failure, we still have little understanding of what causes cast iron to fail and what the mechanisms are. My university degree was actually in materials science, or that was my specialisation. So I ended up going back to the universities and talking with them. And so it's still an area where we're still working on. And in fact, that's a research program we've just kicked out to look at those mechanisms of failure and how leaks deteriorate and how they grow on cast iron pipe. In terms of new materials coming through, no, I agree. I've not seen a lot coming through. I think some of this as well is looking at the material tends to be fine. What tends to be the problem is actually our jointing techniques on it. And if you look at particularly with PE, we produce this wonderful PE pipe in the factory that then comes out, and the first thing we do is start drilling holes in it to make connections. These are the kind of things that we've got to start asking questions about how we join pipe and how we do that side of it.
Yeah. Okay. We've got a question from Ewan, which is, where does the source of funding come from for water utilities to conduct these research programs? Tariffs or national funding?
So the UKWIR funding, the research funding for that comes all from the water companies. Okay, so it actually comes here from our customer tariffs, and as part of that, we fund research jointly together through UKWIR. What's interesting is that the government, through their regulator Ofwat, have for the next 5 years put in an innovation fund for £200 million over 5 years for the UK water industry. That's to kind of give us a bit of a kickstart in terms of innovation, and I'm part of the team that's actually looking at how that will be managed and allocated. In fact, we've just written a joint innovation strategy for the UK, which looks at innovation in the water industry. So that will be coming out for consultation soon.
Okay, and we've got a question from Ian. Are UK water companies using a combination of hydrophones and pressure sensors for leak, burst and transient detection?
Yeah, and that's a really good question, actually, because it is the combination of sensors that a lot of companies are now starting to move towards. So what we're finding typically is if you look at accelerometers, companies are using those, and we're starting to see a number of companies that are doing fixed networks of those, but nobody in the UK is doing that across their entire network. Okay, nobody has been able to put in a justification that their entire network is covered by accelerometers. Typically, you'll find up to a maximum of 50%, but that's quite extraordinary to be that high. Generally lower than that, and the accelerometers are concentrated in the areas of highest leakage, as you'd expect. Hydrophones started to appear. Obviously, the big advantage of hydrophones is the direct contact with water, and therefore you can get away with less sensors as a result of that, lower costs. Sounds great, but all of the evidence that's been gathered at the moment and the work that's taking place has shown that you need to be far more careful in your deployment of hydrophones. It's quite a complex art. I would have to say Anglian Water are probably the leaders in that area in the UK at the moment. They've done an awful lot of work with hydrophones and optimizing the location of those. But because it is quite tricky to do it that way, a number of companies are now saying, okay, we're looking at smart networks. We get a comms layer that goes over the top, and then all of your sensors, pressure, accelerometers, hydrophones, all start to feed into those to gather an evidence base that says, I've got a noise here and a localized drop in pressure as well. And therefore increasing your confidence that there is actually something going on. So my gut reaction is I think that the smart networks will probably be where a lot of companies are starting to move towards. And we're seeing a number of trials in the UK of those.
Right. We've got a question from Stuart, which is the water loss specialist group, obviously, that me and Stuart with, are always looking for new initiatives. And we've got a global group of people in our membership. So would you consider doing this in association with the water loss specialist group to take this worldwide gathering knowledge and data?
Yes, I'm absolutely fine. I think the only thing I would say is I don't want to enter into an exclusive arrangement with any one group.
Yes. Yeah.
As far as I'm concerned, what I want to do is the next time I run this exercise, you know, it would be lovely if each time we run this, it grows and grows and grows, and it becomes an international tool where people can go and say, right, okay, who's working in this area? You know, water, I'm a waterman born and bred, yeah? My job has always been working with water. And so I love this industry, and I want this industry to do well, okay? And that means sharing. That means us going, who's working in similar areas to me, and how can I learn from them and help them? So yeah, I would love to see it being spread wide, and very happy to talk with you guys about the next time we're running this and how we can push this out all across the world.
So there's a question from James, which is, can I ask who are the active players in this area in Australia? I'm based in Australia and would like to get in touch and know more. I don't know if you know that.
Yeah. Straight away off the top of my head, I know that I was talking with Sydney Water, but there was another couple of companies as well who actually sent in their data, but I haven't shown it simply because I didn't feel confident I had enough of an international side from it. James, look, you know, all of you will find this. I'm on LinkedIn. may I suggest you contact me on LinkedIn, and just we'll follow this up, and I'll let you know who is involved from Australia.
I do know that in Victoria, they have a water group where all of the water companies all join together and they share information on studies as well. And I've also in New South Wales, I've been to one where the joint utilities, which tend to be fairly small in the suburbs, they do shared research as well. So there's already some organizations that are doing this sort of work as well, and it would be good to maybe get them involved on an international level.
That would be really useful. And in fact, one of the projects we're doing with UKWIR is we're actually funding some of the research that's happening out in Australia because we recognise the leading work that they're doing. So UKWIR already has that relationship with them. It's just that at the moment we have it's getting this individual project list from companies. That's the kind of next stage on.
So we've got a question from Nicole, which is university research is ongoing, looking at using miniature robots for leak detection, condition assessment, and
I think that is, yes.
For both pressurized and gravity fed systems. She does say below position mapping.
Yeah, no, that's fine. That's okay. So in fact, I was at the launch of that one up in London. So they obviously been working for it for some time, but they did a big launch event, I think just before the lockdown actually, Pipebox, up in London. Yeah, it's really interesting work. The idea of robots going down pipes, and it's interesting that, when you talk about that, people raise their eyebrows, but in my mind, that is the future of where we need to go. It's how we get there, and it's then mapping out that research path for doing it. I'm pretty keen on the idea of autonomous swarms. The idea being is that you have multiple robots going down. One goes past and says, I heard something, and then as the others go past going, yeah, I heard something too, and that starts to build your confidence levels up. Obviously, as soon as you start to talk about this, you've got the whole point of you're introducing something into your clean water supplies. One thing to do it into the sewers, where people are far less worried about contamination. But as soon as you start to put it into clean water supplies, you've got to go through a whole new, gamut of tests just to make sure that there's no danger of contaminating your water supply. And I know that the water quality staff get very nervous about this side of it. But yeah, I think, robots in pipes is one of the ways that we definitely need to be looking at. And obviously the repair techniques that could come from that as well would be really valuable. The ability to repair pipe from the inside would be fantastic without having to dig it up. One of the remarks I make when people look at this program is they say zero leakage by 2050. Surely that's just, that's unachievable. And the example that I use a lot when I talk with people about this is I say, consider cars. A friend of mine had a birthday recently, and we hired out a Tesla for him amongst a bunch of friends just to give him a treat. Remarkable car if you've ever driven one. And we were driving down the motorway, and he went to change lanes. And the sensors on the car stopped him from changing lanes because it recognized there was someone in the outside lane and physically wouldn't allow him to move the car into a dangerous situation. Now let's consider the dribble down of that technology, and in 20 years' time, every car on our roads has that same technology on it. What we've done is we have almost removed the potential for a crash on our roads. What we've not done is change all of the road network. What we've changed is how we transport our cars down that network. Take that same analogy and apply it to water, okay? We are not going to replace our entire network in the next 20 to 30 years. It's just not going to happen. What we need to do is change how we pass water down our pipes. We need to think about how we're doing that and that process. It's taking out the transients that occur on our network. It's repair methods that can go internally without having to shut the network down in order to be able to do it. It's a complete change in thinking in terms of how we handle water. So yeah, it's I am a believer in robots, and it'll be interesting to see where that one develops.
Yeah, Nicole has just commented back saying she agrees that there are a lot of requirements which need to be met for clean water. The ultimate idea is that these robots live in the pipes and hence don't need to be inserted and removed all the time.
Yes, completely get that. The interesting bit with that one is in fact, when I was at the conference up in London, and we were talking about some of the conditions that they would find in the pipes. The problem that we have is that in general, you've got a flow pattern, obviously, within your pipes, and treat it like a river going from a source to the sea, okay? We have the same. So there's effectively generally a flow going through your network in one direction, which is going to carry the robots easily in one direction. But for a robot to have the power and facility to go back upstream is going to be a lot harder. You will tend to find that your robots will congregate at the end of your networks as a result. So yeah, it's not insolvable. It's some of the aspects we've got to think about. Thank you for that. I'm really interested in that as a bit of research.
And we have one comment from Stephen, which is, I agree with Stuart, this would definitely help developing countries, especially the water utilities with budget constraints, which I agree, but then you've got to say, with all of these new technologies, would they cost more than those developing countries would be able to afford to implement anyway? Or do you find some low-cost technologies happening as well?
I think one of the wonderful things is that we're seeing leapfrog technologies coming through at the moment. And by that, I mean where you bypass a complete system of work that other people have put in. So a good example of that is in telecommunications, is there certain countries that never went for copper. By the time they got to doing telecommunications, they just went, we're just going to lay fiber. And they got amazing networks because they just bypassed the entire copper network system that other countries put in. We're seeing that within water. There's certain countries that are developing their water estate. They've come to it, I would say, maybe later than others. But as a result, they go, well, we're not going to do that particular methodology that you guys have all done. We'll just leapfrog the technology and come in straight where we are. I think one of the technologies I think that would be really useful for that is the communication side at the moment is IoT, the Internet of Things. I've been very closely following that in the UK and the development of the Internet of Things. And one of the chief people within the water industry saying this is going to be a real groundbreaking change because it massively lowers the cost of getting communication back from your devices. And our experiences have shown that you get far better coverage from the IoT devices. We get far less dropout when they're underneath metal covers, and we can get a far higher data rate. We're now moving to, in the UK, the standard used to be 15-minute data as a granularity, coming back every hour or every couple of hours as a frequency. We're now running our network on 1-minute granularity, 15-minute frequency, and that's as a result of the IoT solutions. So I think, in a lot of the countries that maybe, as I've said, water utilities with budget constraints, one of the things is to look at these new technologies, particularly in communications, that can have a massive benefit, and you just bypass a complete system of work that some of the other companies have got.
Okay, well, we don't have any more questions unless anybody's got a last minute question for Jeremy. No, I don't think so. So thank you very much, Jeremy. That was very interesting. And if anybody like James or would like to get involved in this, then please contact Jeremy directly. And I know that Stuart and myself will be talking to you further as well, see how the water loss specialist group can get involved. So with that, I'd like to say thanks very much, Jeremy.
Thank you very much for giving me this opportunity to talk.